Hello and welcome to another Algebra 1 video tutorial. In Lesson 10.7 we'll be looking at matrices and matrix multiplication. Our goal will be to multiply 2 by 2 matrices by 2 by 1 or 2 by 2 matrices and represent a system in matrix form. So the big idea here, rectangular arrays, which we call matrices, can sometimes be multiplied and represent systems of linear equations, which is what we've been solving for the last 6 sections. Okay, so in general, the matrix form of the system, ax plus by equals e and cx plus dy equals f, is going to be this. We have these brackets, and we put inside them numbers. Okay, in this case we have 2 rows and 2 columns. So this is a 2 by 2. Here we have 2 rows and 1 column, and another 2 rows with 1 column. So we would say this is a 2 by 1 matrix, a 2 by 1 matrix, and this was a 2 by 2 matrix. Okay, but that represents the system right here. Okay, so this thing right here, this first one, is the coefficient matrix, because look at this. The A, the B, the C, and the D, they are the coefficients of the variables. So this one is called the variable matrix. And what they're equivalent to is the constant matrix. So usually these are just a constant number that we've looked at for the last 2 sections. I've solved these using the multiplication and elimination method, which is the addition elimination method. And now we can use a matrix to represent kind of the structure of a coefficient matrix, a variable matrix, and a constant matrix. Okay, so write 3x minus 4y equals 5 and 4x plus 8y equals 2 in matrix form. Okay, so matrix form, we're going to need the coefficient matrix. So it's going to be the 3. All right, so this is going to be a minus 4 or plus negative 4. So the first entry in the first row, first column, is 3. Then we have in the first row, second column, we have negative 4. Then we have the 4 and the 8. 4 and the 8. So in the second row, first column, we have 4. Second row, second column, we have the 8. Times by the variable matrix, and we got them lined up, and they're x is y, x first, y second. Okay, and that's in a 2 by 1 matrix, and then it equals the constant matrix 5, 2. Okay, so it's fairly simple. The only thing you might be careful with is getting the signs in here correctly. If you have a minus 4, that would be a negative 4, because we could treat this as plus negative 4y, and then you can see how the entries match up there. All right, right. 4x equals 5y plus 10, and 2x minus 3y equals 20 in matrix form. Right away, you can hopefully see that this is not set up in the correct form. We want these in standard form, so we would need to subtract 5y from both sides. So we should first rewrite this in standard form. 4x minus 5y equals 10. Okay, and then the bottom one is good. 2x minus 3y equals 20. So that's first how you should rewrite your system in standard form. Now you can go ahead and use matrix form. So think about what would be your entries. It's going to need to be a 2 by 2. So it's going to be 4, negative 5, right? 4 minus 5y. Okay, 2x minus 3y. Okay, there's our coefficient matrix. Now our variable matrix would be xy. Now if we'd had y's first, x's second, we'd put y up here, x down there, but we don't have that. Okay, equals 10, 20. All right, so you should be able to get in the hang of, it's not that difficult, get in the hang of writing a linear system in matrix form. All right, now what if we're given the matrix equation? It's a 2 by 2, 2, negative 6, negative 5, 1. Times a 2 by 1 variable matrix xy, and it's equivalent to a 2 by 1 matrix 12, negative 17. This describes a system of equations. What is the system? Let's write it. Okay, so the system of equations, well, it's going to be, basically we can put in x's and y's here. So it's going to be 2x, right, because we'd multiply 2 times x. Now we haven't got into multiplying these yet, but we're getting the hang of it. This is leading us into that. So it'd be 2 times x plus negative 6 times y, which we could just say minus 6y, equals, it's going to equal to 12. All right, now we move to the second row with the 1 column here. So we see what we're going to do is we're going to multiply rows by columns and the corresponding entries in each. So the 2 times the x, then negative 6 times the y. Now on the bottom one, negative 5 times the x, so the first entry in the second row with the first entry in the first column. So we go rows by columns, first entry in the first column. So it's going to be negative 5x plus 1y equals negative 17. So if we multiply this row with this column, we get 2x minus 6y. And if we multiply the second row with the one column, we get negative 5x plus y. And then it equals 12 and negative 17. Okay, so that will lead us into how would we perform the multiplication on a 2 by 2 matrix. This has 2 rows, 2 columns, and then we're going to multiply that by a 2 row 1 column. 2 row 1 column. Now what's going to happen is the rows by column, this column has to match up with the number of rows in this. If these two numbers don't match up, you are not able to multiply these. Okay, so this tells you if it's true. The outer two, the rows in the first and the columns in the second, that's going to be the size of the new matrix. So if you multiply a 2 by 2 by a 2 by 1, the result is going to be a 2 by 1. Okay, so if we multiply that, we're looking for a 2 by 1. So there's going to be one entry here, one entry here. Now let me actually do that multiplication to show you, because it's going to take a little monkeying around to get the hang of that. So you're going to go the first entry here with the first entry here. So it's going to go 4 times 2 plus now the second entry with the second entry. Okay, rows by columns plus negative 6 times negative 4. Okay, now for this bottom entry here, we're going to go this row with this one column. So negative 2 times 2 plus negative 3 times negative 4. Okay, so I did this row with this column and then the corresponding entries in each. So now what I'm going to get, I'm going to get 8 plus 24, and I'm going to get negative 4 plus 12, and my final answer is 32, 8. So if I multiply these two together, the result is a 2 by 1 matrix. 32, 8 is how you would read that. All right, now what if you have to multiply a 2 by 2 with a 2 by 2? What would the size be? Well, first of all, can you do that? A 2 by 2 multiplied by a 2 by 2. So you check these two numbers. Yeah, they match up, so we can do that. So the columns in the first match the rows in the second matrix. Okay. What this result is going to be is these two. So it's good. The result is going to be a 2 by 2. A 2 by 2. So we're looking for a matrix that has 4 entries, right? A 2 by 2. 2 rows, 2 columns. Okay, so now let's actually multiply that. So we're going to go for the upper left entry. That's how I say this, is the upper row with the left column. So it's going to be negative 2 times 2, negative 2 times 2, plus negative 1 times 8. Now you can do this mentally if you want to. All right, now for the upper right entry, we go upper row with the right column. So it's going to be negative 2 times 5 plus negative 1 times 1. Upper with the right. Okay, so for the upper right entry in this 2 by 2. Now for the lower left entry, we go the lower row with the left column. So we go 5 times 2 plus 3 times 8. Okay, now for the lower right, we go the lower row with the right column. So we're going to go 5 times 5 plus 3 times 1. All right, and then we just crunch the numbers on this to get our answer. So we'd get negative 4 plus negative 8, so that's negative 12. Negative 10 plus negative 1 is negative 11. 10 plus 24 is 34. 25 plus 3 would be 28. So the resulting matrix would be negative 12, negative 11, 34, 28. All right, this wraps this up. Your assignment will be 10-7, page 625, 2 to 22 evens. Don't be afraid to watch that multiplication a few times if you want to see how to do that by hand. I will also show you on a calculator at a later date. All right, thanks for watching. We'll see you next time.